Hey guys, and welcome to this video on the R programming language. So today I want to talk about multiple linear regression in R and how to implement it on R Studio here. So let's go ahead and get started. First thing that we're going to need to do is gather our data set, and I've already have a data set, a CSV file here called realestate.csv, and I got this from online, and I'll put the link in the description below so you too can gather this data. So what we're going to do first is create a variable. I'm going to call it my data, and then we're going to use the read.csv function to read in our CSV file. Now we need to know the location of the file and the name of the file. So I'm going to go ahead and right click up here and click properties onto our file, and then we're going to get the location. So I'm just going to copy that and I'm going to paste it right here. Okay, and then, oh, looks like it didn't go within the quotes. So I'm going to put that within the quotations. And then I'm going to get the name of the file as well, and then put a slash and paste it here. And I'm going to change some of these other slashes to the opposite slash because I'm using Windows. But this right here will go ahead and work. So you see that now we have created our data frame. And I'm maximizing the screen here so that you all can see better. So now we have our data frame. Again, I changed the slashes, I reversed them, and you'll have to do the same if you're using a Windows computer. So let's take a look at our data frame. It has 781 rows of data and 8 columns. So all I have to do is just click here, and then we can view our data, and we can take a look to see what we're working with. So basically what I want to do is I only want to work with numbers here to show you guys how to use multiple linear regression. And the column location and the column status have words and not just numbers. So we're going to create our own data set without these two columns. Now, let me go ahead and explain to you what each column means and what they represent. So MLS is multiple listing service number for the house. It's basically a unique ID. Location is the city or town where the house is located. Price is the most recent listing of the house in dollars. And then bedrooms is the number of bedrooms. Bathrooms, the number of bathrooms. Size is the size of the house in square feet. And then price.sq.ft is the price of the house per square foot. And then status is the type of sale, and there are basically three: short sale, foreclosure, and regular sale. So let's go ahead and continue now. Again, we're going to create our own data. So I'm going to create a new variable and call it my data2, and I'm going to set it equal to my data, but this time I only want columns 1, which is the MLS column. I want column 3, 4, 5, 6, and 7. Okay, and so that should give us our new data set. So here we have 781 rows with 6 columns. Let's take a look, and there we go. We have 781 rows, and then we only have 1, 2, 3, 4, 5, 6 columns. Okay, so let's go ahead and create our linear model now. So I'm going to create another variable and call it linmod, and I'm going to set it equal to our lm function, which is our linear model function that we're going to be using. And what do we want to predict here? Well, I want to predict the price based off of all of these other features. So based off of MLS, bedrooms, bathroom size, price.sq.ft. So what we have to do is we have to tell it what we want to predict, which is the price. And then we have to give it all of the features that will help make this prediction. So that will be our MLS, that will be our bedrooms with the S, that will be our bathrooms, that's also with an S, and then our size, and then the price dot Okay, and then we have to tell it the data set that we want to use, and the data is going to be my data 2. And we just press enter, and so now we have our linear model. So let's go ahead and take a look at our linear model. Well, actually, let's get a summary of our linear model first. So summary of our linear model. And now this right here will give us our residuals. It gives us our coefficients and our p-values. So we can also tell how significant our variables are visually with these stars. And usually we want our p-value up here to be, I think it's 0.5 or less, or it's either less than 0.5. I'm sorry, it's either less than 0.05 or less than and equal to 0.05. I actually cannot remember off the top of my head right now, but we can see that this is definitely less than 0.05, and these two columns are less than 0.05. So we can also see this visually with the significant codes down here. 3 stars is very significant, then it just goes down from there. 2 stars, then 1 star, then a dot, then nothing. So we can see that we have 3 significant features here. Really just 2, because this is our intercept. Okay, so let's go ahead and continue here. So now let's take a look at our linear model. And now we can see all of our coefficients for each variable. So let's try to make a prediction here. Let's gather an example from the table up here. And let's try to predict the price using these coefficients. Okay, so what we're going to do is I'm going to create a variable called price, and I'm going to set it equal to negative 7.34. I'm not writing this out. I'm just going to copy this right here. Copy and paste. And then plus, I'm going to use this last row here, row 781, to try to predict its price. So we need MLS, and MLS is right here. So I'm just going to copy that, paste it here, and then we're going to multiply MLS by its coefficient. Just going to copy that and paste it here. And then we're going to add some more. Next up is the bedrooms. So I'm going to grab the bedroom here, which is just 3. So we're going to do 3 times that there, that coefficient. And then plus, we need bathrooms. Like bathrooms is also 3. So I'm just going to type 3 times the bathrooms coefficient plus the size, which is 2392. And then we're going to multiply that by its coefficient. And then we need our price.sq.ft, which is 459.87. And let's see how close we get to the price. So the price should be somewhere around 100 and wow, actually it's hard to see. That looks like a million. So 1,100,000. Okay, so let's see if this is accurate. Let's print the price. And here we get 1,023,000. So that's off by a good 70 $6,000 or so dollars, which is pretty significant. But I guess if you're buying a $1 million house, you might not really care about $76,000. But that's basically it. That's how it works. I hope you guys enjoyed this video. Please leave any likes, questions, comments that you have for the video. And as always, thanks for watching, and I see y'all in the next one.